Okay, welcome back. For today's lesson, we're going to be going over the Benchmark 2 study guide. So you're going to log into Live Worksheets with your student ID, which is your Google ID, without the at louisa.org, without the at k12louisa.org, and the password is Bobcat2020. You're going to pick the Benchmark 2 study guide. And we're going to be reviewing some of the concepts that will be covered on the second benchmark. Okay. So the first thing is looking at this graph, and it shows months of the year along the horizontal axis here, which is the X, and the axis going up and down is the Y. So it's what variable is plotted along the X-axis. We see months of the year is on the X-axis. And what variable is plotted on the Y-axis? Over here we see the temperature. Okay, then the next question says, what is the IV, or the independent variable? The independent variable is always on the x-axis. So the independent variable is the months of the year. And what we think might depend on what month it is would be the temperature. So for example, in December, we expect it to be a lower temperature. We would think that the temperature might depend on what month it is. Like in January and February, it's cold. And in August and September, the temperature is higher because the temperature depends on the month of the year. At the beginning of the year, we learned about metric conversions. And we used the acronym King Henry died unusually drinking chocolate milk. And the prefix on the second row, it says put in the prefix, the K stands for kilo, the H stands for hecto, the D stands for deca, the D on the other side of the decimal point stands for deci, then centi, and then milli. Okay, now it says convert 105.6 kilograms to grams. So we learned about the swoop method. We find the beginning prefix, which is kilo, and we count how many swoops it takes to go to where we want to end up, which is the base unit grams. So we swoop 1, 2, 3 to get to the base unit. So we have 105, and then we're going to swoop once, twice, 3 times. So it would be 105,600. How many millimeters are in a meter? Well, we find milli, and we want to get to the base unit meter. So we have to go 1, 2, 3 swoops. 3 swoops is 3 zeros. So it would be 1,000. How many centimeters in a meter? There's 1, 2 swoops. So there'd be 2 zeros. So it'd be 100. And then in a decimeter, there's 1 swoop. So it'd be 10. How many meters are in a hectometer? Okay, so we have 1, 2 swoops, so that would be 100. Okay, early in the year in Unit 3, we learned that elements in the same family or group have the same number of valence electrons. In the formula CO2, the small number written below is called a sub. Below the writing, which is script. Metals are located on the left side of the periodic table. We start with the alkali metals in the first column, and then the alkali earth metals, and then the transition metals in the middle. Most of the mass of an atom is in the nucleus. And in the nucleus were the protons, which are positive, and the neutrons are neutral. When an element in group 2, which is a metal, bonds, it will transfer 2 valence electrons and form an ionic bond with a nonmetal. Remember, ionic bonds were always between a metal and a nonmetal. In group 6 or 16, and then we have the 2 plus the 6 is 8, which is a full energy level. As a gas like CO2 cools, the motion of the particles slows down because they get less energy, so they would decrease in speed. Okay, we're finished with that page, and we're going to take a look at the second page of review. We just said on the first page, when a metal bonds with a nonmetal, that is an ionic bond. When two nonmetals bonded, like O2, they always formed covalent bonds. So when two nonmetals bond, it forms a covalent bond. Number 11 says the atomic number of an element is 8. What is the atomic number of an element that has 8 protons and 8 neutrons? Well, the atomic number is equal to the number of protons in the nucleus, so the atomic number would be 8. And then we can look at the periodic table and find out that the atomic number of an element that is 8 is oxygen. For most substances, as the temperature increases. So early in the year, we looked at how things behaved when they increase and the motion of the particles increases and they move faster and faster, they spread farther and farther apart. So the volume of the substance will increase. And as what we're changing is the temperature decreases, the volume will go back down. So as we warm it, it expands. And as we cool it, it contracts. And this increase in volume or decrease is called thermal expansion. Okay, so its name is right here. Okay, temperature goes up, thermal, and what happens? It's bigger. Okay? So it expands. Anything that has mass or takes up space, which is volume, is the basic definition of matter. Okay, now it asks us to identify things as a physical property, a physical change, a chemical property, or a chemical change. Remember, a property describes something. So a physical property, it describes something that we can detect with our 5 senses or measure. A change is in one of those things, so it's actually happening. Chemical property describes how it would react. The chemical change is it's actually doing that. So the changes are actually things that are happening, they're being done. Okay, so we're going to look at the first one, NaHCO3. That's a formula. That just describes the substance. So that's a physical property. If it's boiling, ing is an action word, so it's happening, it's changing. And when substances change phase, the liquid water is water and the steam above it is water, so that would be a physical change. Now this one says what will happen. Vinegar will bubble when mixed with baking soda. That describes how it's going to react. So that is a chemical property. Cooking, again, is an action word. The ing means it's happening. So it's actually changing, it's going on. Okay, and when we said always, cooking is always a chemical change. Iron is rusting. It's actually happening. Okay, rusting is making a new substance. So this again would be a chemical change. Texture describes the substance, whether it's rough or it's smooth, but it's not happening, so it's not an action, it's not a change. Okay, so it describes something that we can observe with our 5 senses or measure. Okay, we can observe the roughness with our 5 senses, so it would be a physical property. Wood burns. That describes what wood will do around heat, and it'll make a new substance, which would be gaseous. So we know it's chemical, but the wood it just says this is what the wood will do with heat. So this is a chemical property. Apple slices turn brown in the air. Okay, so we know that if we cut an apple and stick the things up, that's what they'll do. So it describes it. So this is a property, but it describes how it's going to react with the air. So this is a chemical property. The water is at room temperature. Okay, this describes the water, so it's not a change, it's not an action happening, so it's a property. And it's a physical property because it's something that we can measure, we can observe with our 5 senses, or measure without having a new substance. Water freezing, this again is an action word. This is happening, so it's a change. Is it making a new substance? No. Liquid water is H2O. Ice, frozen water, is H2O. So this is physical, but it's happening. So this is a physical change. Digesting your lunch. This is an action word. So this is a change. So We have to decide if it's physical or chemical. Now, does it make a new substance? Yes. Okay. When you digest your lunch, there is a new substance. Okay? It's not going to come out being bread and whatever you had. Okay. The color of something describes it. This is not an action, so it's a property. Is it a physical property or a chemical property? Well, it's something that we can detect with our five senses. We can see it or measure without making a new substance, so it's a physical property. In basic definitions of solids, liquids, and gases. Solids have a definite shape, yes. Solids have a definite volume, and that is the definition of a solid. A solid is a substance that has a definite shape and a definite volume. Liquids, when you pour them into a new container, do not have a definite shape, and they do maintain their volume. Okay. Gas does not have a definite shape, and gases can expand or contract, so they do not have a definition, definite volume. And these are actually the definitions of a substance. A liquid is a substance that does not have a definite shape, but does have a definite volume. A gas is a substance that does not have a definite shape and does not have a definite volume. So you can get this filled out on a test, and you make yourself a little thing. There you go, you get the answers to the definitions of all three phases of matter. Fourth state of matter, free floating gas with ionized electrons and a high stage density made of charged particles. This is plasma. Let's take a look at this third page. Okay. It says balance this. Okay. There's two hydrogens, there's two oxygens on this side and one on this side. So I'm going to need to put a 2 here. Okay, 2 times 2 is 4 hydrogens, but I only have 2 over here, so I need to put a 2 here. 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. There's 2 oxygens over here, and remember there's an understood 1 here, so 2 times 1 is 2 oxygens, so this would just have a 1 coefficient. Reactants are the things that we begin with. So the reactants are the H2 and the O2. The product is what gets made. So it would be the H2O. Draw a line to each model, the Bohr model and the electron cloud. The Bohr model is this one that shows the electrons in orbit. The electron cloud is this one that sort of looks like a shotgun pattern. It shows all the places where the electrons could be. Which is the most modern one? It's the electron cloud. We use the Bohr model one in class because it's a little easier to understand. Well, it's a lot easier to understand. Okay. Compare the Bohr model to the modern model. The number of electrons in an atom do not change. Okay, so that's the same. We figure that out from the periodic table. The number of electrons is always equal to the number of protons. Doesn't matter what model you're using. Mass of the atomic particles does not change. The shape of the nucleus is tiny. They're in the center in both of them. So that is the same. The arrangement of the electrons. Well, yeah, look at this arrangement and this arrangement. So that is different. And the electrons move in energy levels. Both of them show that the electrons move in energy levels. This just shows that it's flat and they're kind of going around like in orbits. Whereas this one has like all the places around the atom where the electron could be found. So this is the same. They both move in energy levels. Number 20 here, it says count the atoms in the formula, C7, H5, and O2, with 3 on the outside of what's inside the parentheses. So we have 7 carbons. Little 5 means we have 5 hydrogens. And then this 3 applies to everything inside the parentheses. So remember, there's an understood 1 here. So 3 times 1 is 3 nitrogens. And 3 times 2 is 6 oxygens. On this one, there's 1 calcium. 2 times 2 is 4 hydrogens because the 2 goes to everything inside the parentheses. There's a 1 here by the P, so 2 times 1 is 2. And then 2 times 2, or 2 times 4 is 8. Okay, these two things with formulas, they are not elements. Okay, there's element carbon, hydrogen, nitrogen. There's different elements in the formula. They are a compound. They are not a mixture, and they are not an abbreviation. On the periodic table, number 21, it says which elements are most like oxygen. Well, the ones that are most like oxygen are the ones that are going to be in the same family going up and down. Okay, so you're going to find the family with oxygen and see the elements that are the same in it. So I'm going to look at the periodic table, and the oxygen is at the top of family 6, and in it, right under it, is sulfur, and under sulfur is selenium, and under selenium is tellurium, and under Te is polonium. Okay, and you should probably be like, Mr. Palmer, you didn't capitalize the T. You all know that the first letter of any element symbol is a capital letter. This is because they are in the same family. That means they had the same number of valence electrons, so they have similar bonding properties. Chemical change. The way when we were just classifying the stuff and we knew if something was a chemical change is because it always produces a new substance. It involves a change in energy. So things either absorb energy or they release energy, but the energy never stays the same. Noble gases are the elements that are all the way over at that last family, the very last column, okay, which is family 8. And then the first one in family 8 is helium. And right under helium is neon. Right underneath neon is argon. And right under argon is krypton. And right under krypton is xenon. And right under xenon is radon. Okay? And they are all non-reactive. Remember, the noble gases don't react. So it says the noble gases do or do not bond with the other elements because they have a full power. Okay, we're going to stop here. Next time, we're going to do the next 2 pages.